So just want to do a quick recap of the product rule, quotient rule, and then I want to take a look at something called higher order derivatives. Okay, and what that means. It means taking the derivatives many times down the line. So all right, as you know, there's lots and lots and lots of questions that I give you in your assignment. Okay, my job here is to make sure that you understand the fundamentals of it, and then you have to go ahead and take it from there. So let's do product rule. So example, you do this one. Let's say f of x is equal to the cosine of x times the square root of x. Cosine of x times the square root of x. Find me the derivative of that using the product rule. Okay, you get that? Just running through it again. Product rule says you take the derivative of the first function, and then you bring down the second function, multiply those, plus bring down the first function, multiply it by the derivative of the second. And just so we know, this is how you take the derivative of a radical. You got to write it with an exponent, that is the fraction, and then you apply the power rule. So 1/2 x to the negative 1/2, and then just clean it up, and that's 1 over 2 square roots of x. Bailey.
So you said after the x to the 1/2 that's on the bottom?
Yep.
You should turn it back into the square root.
You can do it either way. On the AP exam, you may see it with a square root, but you also may see it as x to the 1/2.
Okay.
So I'd say just be familiar with both of them. Okay? And then we could have some form that looks like that. All right, second one, quotient rule. That's the one that we learned yesterday. If you need to refer back to your notes from yesterday, do that. But find me the derivative of that function using the quotient rule. That's a brand new word.
We should make an AP Calc dictionary.
Yeah. This is higher order derivatives.
We should make a dictionary.
Make our own dictionary. Okay. Okay, compare that step. That's a crucial step because that's finding the derivative using the quotient rule. How many people got that step right? Okay, awesome. And then just cleaning it up, I don't know if there's anything else we can do with it. You would write 2x sine of x minus x squared cosine of x all over sine squared x. And that would be, that'd be about as far as I'd go with it. Okay, good? Okay, that's a fundamental, these are two fundamental rules that are now going to be used when we find, when we continue to find derivatives. We got to remember these guys. Okay. Somebody asked me yesterday, hey, is there like a cheat sheet that you get on the exam that has all the rules on it? And the answer is no. You go in with your brain and a pencil. Okay, so they don't give you anything extra. So you got to, this is why you got to do these so many times. You're just like, sure, I know how to do that. That's no biggie. You can do that. Okay, yes.
Does it matter if you flip-flop, like, in the quotient rule, if you had it be f prime of x times g of x minus g prime of x times x?
As long as these two, okay, that's a great question. Let's look at this rule. So the rule looks like this. Quotient rule, if f of x, I'll say h, I'll use h again. H of x is equal to f divided by g. Then h prime of x is equal to g times f prime minus f times g prime all over g squared. Right? Is it legal to write, I gotta see if I'm understanding the question. Can you write it like this, f g prime minus g f prime?
Yeah.
Okay, everybody look closely at that. Is this okay?
But, some of those, if you just had f prime times g.
Okay, that's a different question. So, first of all, is this the same as this? No. Make sure you see that these are not equal because of the minus. Okay. If I swapped this one with this one, is that legal? Yes. Okay. And if I swap this one with this one, that's legal. And the same thing goes with the product rule. Because it's a plus, the derivative of f times g, it's f g prime plus f prime g, or f prime g plus f g prime. You know, because we're adding. Just everybody gets to be the derivative, and everybody has to sit out once. Take turns. By the way, a little side note here. Extending the product rule, let's suppose h was equal to f times g times w. Three functions being multiplied together. What would you guess? F prime times g times w plus f g prime w. And that works. That's correct. Kind of cool. So it works out. We can do a proof of that as well. This proof would look similar to the one that we watched on the YouTube video, except there would be three of them. Okay, to the backboard. Higher order derivatives. This means finding the second derivative, the third derivative, the fourth derivative, and so on. Okay. So, we're good to go. Okay. So, let me put it in notation form. Okay, first. So, if I had f of x is my function, okay, then my first derivative would be f prime. Okay. If I took the derivative of the derivative, it's f double prime. If you took the derivative of that derivative, it's f triple prime. Okay? You can keep on going as long as you can, but you stop putting tallies after that one, and then you put a 4 here. Okay? In practical terms, the only person that goes to this point are mechanical engineers. Okay? Because what happens here, this is the function. The derivative, if this is the position function, then the first derivative is the velocity. The next one is the acceleration. And this one is jerk. And then they don't use, to my knowledge, they use anything past that. But you can use the fourth derivative to find out more about that. So, and here's what's cool. Velocity is change in position. Acceleration is change in velocity. Jerk is change in acceleration. It just goes boom, 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 all the way down the line. Okay, all right, so that's if the notation looks like that. But then you can just use different things like this. So if I have y, I can go y prime, y double prime, y triple prime. So when you see that notation, that's what we know that we're doing. It's the first derivative, the second derivative, the third derivative. Now, this is the one where it gets a little weird. If you have y as a function, I can use this notation called dy dx. Okay? dy dx is the notation for the derivative of the function y with respect to the x variable. Okay? The second derivative notation looks like this. It's d squared y over dx squared. And yes, I put those 2's in the right spot. I'll explain why it looks like that. And then the third derivative is d cubed y over dx cubed. Okay. So you'll see all these kinds of notations here. So let me explain. Let's take a random function and find the derivative of it using the notation. So here's an example. Let's suppose y is equal to the sine of x. Okay, y is equal to sine. Let's go down the line and we'll take multiple derivatives of this. Okay, so what I'm going to do is I'm going to use this one, this notation here, to explain what's really going on here, what all those dy dx's mean. And you know how in the past we've done this ever since you learned algebra. Remember, we can like take the square root of both sides of an equation, or we can take the natural log of both sides of the equation. What we're going to do right now is we're going to find the derivative of both sides of the equation. Okay, so now watch this. It's like an intricate little skill that actually turns out pretty cool. So we're going to find the derivative of both sides. Okay. So notice how I wrote that. This was the original equation, y is equal to the sine of x. And then I'm going to apply the derivative to both sides. Okay. So this notation here, the top D means find the derivative. The x tells you what variable is supposed to be in here, and this one's supposed to have x's in it, and it does. This variable has to match the variable that's in it. Now this can actually be rewritten as dy dx. Okay? And then here, whenever you see this notation, it says find the derivative of the sine of x with respect to the x. Well, that's just the cosine of x. Okay? So what we've just done here is this is the first derivative. Okay? That's where the dy dx comes from when we do that. Okay? Now let's find the derivative of the derivative. So watch this notation. This is the key right here. So what I'm going to do is I'm going to do the same thing I did up there, where I'm finding the derivative of the derivative. Okay? So the derivative of dy dx and the derivative of the cosine. Same exact step, finding the derivative of both sides. But now watch what happens, and this is where the d's come in, why it's going to look like this. Look at your top. D, dy. You think of it as d times d, and you get d squared. That's the top. On the bottom, you get a dx of a dx, and that means it's dx squared. The thing to note here is that dx squared means dx squared. Okay? That's the thing to note here. This doesn't mean x squared. Dx comes glued together. Leibniz actually thought of this notation, and we still use it today. It's extremely clever. Okay, so the derivative of the cosine is the negative sign. Okay, and so what we've just done now is we've found the second derivative. Okay, well, let's keep on going here. Let's find the derivative of the second derivative. Now I think I can go all blue here. D dx of d squared y over dx equals d dx of the cosine of x. Oh, my bad. Thank you. Negative sine of x. I love looking out at you guys and you're like, huh? Okay. Do you see now how it's d times d squared? So that's where it becomes d cubed.
Isn't the bottom should be dx squared?
Oh yeah, right here. Put the little 2 right here. See, what would I do without you guys? So it's d cubed now, y, over dx cubed. What's the derivative of the negative sign? Negative cosine. And what we have done here is that's the third derivative. Okay, do the fourth derivative on your own. And make sure your notation is correct. There's your fourth derivative. That's my phone. Oh, it's a missed call. I thought it was one of my co-authors. I was a doctor. I think I've got an appointment on Friday. I got to tell you who I thought it was. You guys know that I'm writing a book?
Yes.
Okay.
Yes.
I didn't know this.
I know.
Yeah.
Seriously?
Oh. Okay. Well, it really doesn't need to be on there, but okay. So a year ago, I got called by a publishing company out of New York City, and they asked me to write an AP Computer Science review book. You know the 5 Steps to a 5 series?
Yeah.
Okay, so I've spent the last year writing the AP Computer Science version of the 5 Steps to a 5. And we're at like about 400 pages. Mr. Chamberlain worked on all of the exercises and the problems and all that, and I wrote all the text, like how do you explain everything for computer science. So I enlisted one other person in the job, and it's this lady named Carol, and she lives in California, and we've never met. We've just met through email. And she's helping out on the final stages of the project. So I just talked with her like before class, and so that's what I thought. I thought it was her. So, yeah. My deadline is November 1st. Yeah. So it has been a really long and hard project to do. I mean, just imagine this. You got an essay to write, right? And it's like, what, a 5-page essay, maybe 10 pages. This is a 400-page essay. And it has to be original. You know what I mean? It's got to be original work. I can't just copy it from someplace else. Yeah. The whole thing was finished September 1st, before school started. And then I had a whole mess of people read it and then find all mistakes and suggestions for how they do it. So I've been and Megan was one of the people who did a review. So Megan's name will be in the book and in the acknowledgement section for being a reviewer of the book. So you buy a book, I'll sign it. Yeah. I still don't know how they got my name, because I'm like nobody, you know. I know I don't have that. But I would say that over the last 5 years, I've been kind of active in the Wisconsin computer science thing, and I'm a certified ALICE trainer for this program called ALICE, and so I've gone to different states to present and I wrote exercises for their book previously, so I don't know, but it was a pretty random call. So wrote a book, and it's going to be like on like you can go to Amazon and buy it. You can go to Barnes and Noble. It'll be on the shelves in the summer. Well, I think we're going to print them out for you guys.
Okay, thank you.
Wait, so it's like can you explain the book again?
AP Computer Science is a class and a test where you learn how to program.
Yeah.
And so the book prepares you for how to pass the test.
Okay, so it's like one of those paperback books that we got for the
Yeah,
calculus?
yeah, it's like that.
Okay, is there problems? How do you
Yeah, so I explain each chapter, and then there's problems after that.
It's so cool.
Yeah,
I thought your Alice thing was cool. You showed me again
know.
then, and I was like, what?
yeah. So
Have you seen it? It's so cool. He made all you guys. Okay, explain that one now.
okay.
Who needs help?
Yeah, so there is this. Anybody who's taken Computer Science 1 has learned this program called Alice. It's an introductory language for learning how to program. And I got to know the people really well because I went to 4 of their sessions where they were explaining it. And one was in California, one was in Las Vegas, one was in at Duke University. And every time I'd go, I'd say, hey, I got to show you what my kids are doing. And I'd show them projects that the kids were making. And they were like, wow, that's pretty innovative. We haven't seen anything like that before. So when it came time for them to write the 3rd edition to their Learning to Program in Alice book, they said, well, our publisher had picked somebody to do the exercises, the new exercises. But we don't want that person. We want you. I was like, really? So I wrote 30 original exercises, stealing ideas from what the kids did. Some of them. But I put every one of their names got into the book. One of them was my son Tommy. So Tommy and Scott Ruprecht, Justin Scroggins. Yeah, so their names are in the book because of that. So that's kind of cool. So anyway, so that's who I thought was calling. Yeah.
I feel like your next book should be a motivational, how to learn for real. You know?
Yeah.
Yeah.
Just like Philosophies by Dr. J.
My what's ironic about that is I had an idea for a book about 10 years ago, and I got the title. I don't have any of the material, but some of it. And the title was no, I forgot. Oh, the bell curve of life. The bell curve of life. Because when you draw, okay, here we go. So here's some of my theories that I thought could go into the book are there's a lot of things that are similar on this end, like this is when you're born, okay, and then this is when you're on your final stages. And there's so many things that are similar at different stages, okay. Just one, for example, how much responsibility you have when you're really super young. Like none, right? And then how much responsibility do you have when you're super old? No. But right about the age where your parents are, okay, which is about the average age, which is like the mean, right, of the age. So right here is when you actually have the most responsibility. You know what I mean? And that's why your parents are always mean right now.
It's got a copyright notice or whatever, so no one steals it. So because we're a baby, we're considered unusual because there's more than 2 standard deviations.
Yeah. And then that's the thing, you can talk about being 1 standard deviation away and 2 standard deviations. and then it could be like, how much stuff do you own? Okay, not much. Boatloads of stuff. And then you get rid of stuff down here. And what we're going to learn is in calculus, the area under the curve, okay, is one of the things in calculus, which is the second semester. It's an accumulation function. So it's like all of your experiences are an accumulation as every day that goes by. You're accumulating all of this stuff for that. So I feel like there's enough in there to write a book, but maybe add some other stuff into it. But
You gotta say this idea is yours and no one can take
yeah, this is my idea. You can't take it. It's dated, whatever today is.
Back to the Future, come on.
Back to the Future Day.
Yes.
Hey, we're having a movie tonight.
Yeah. You can all come to the movie tonight. Computer Science has got the auditorium reserved,
Someone from California is gonna show up now.
free popcorn. Yeah, that's okay. And we got free popcorn. Starts at 6:30 sharp. So
I'm getting front row seats. I'm just like,